The motion status panel in PMM gives us an indication what's going on with the controller right now. We are online, we are enabled, so we can run our program by going into the toolbar and then selecting our program. I just have one program, which is program 0. The first thing we do in our program is enable the drives, and then it starts commanding motion. And then you can see that the program is running. That's bit 1024. The line that it's actually currently on, and this will increment as the program is running. The master is moving. This means that any of the 4 axes, which are all attached to the same master, are moving. That indicates that motion is going on. And you can see the actual position is changing and the commanded position is changing. The AcroBasic programming language is really based around the bits and the parameters, and this has some of the more common bits and parameters on the screen. If you float your mouse over, like bit 8465 appears, that's the axis 0 when that's energized. That is bit 8465. So if you want to see if it's enabled within a program, you could use bit 8465. These are all separated by 32 for each axis, so it's 8497 for axis 1, add another 32, 8529, and then 8561. And there's bits for that if you're doing a gearing or a camming, or if you're doing a single axis jog, which is a little bit different than a interpolated master move, and we'll get into that later. And then the actual position is actually 2 parameters. It's P12290, which is in raw counts. For on a stepper, it would be the number of step counts going to the stepper. On a servo, it would be the number of encoder counts, and it's divided by P12375, which is the axis PPU. And that is configured in the configuration wizard on the scaling screen. So it's those 2 parameters, 1 divided by the scaling, and that gets you the actual, and then the commanded is shown, as well as the velocity. For an open loop stepper, the actual and the commanded will always match. If it's a closed loop stepper, then it will be based on the encoder. If it's a servo, the difference would be your position tracking arrow. So, and then if we want to, I think my program ended, so if I run it again, I can kill all the motion by doing this, and you'll notice that the program didn't stop running right away. Killing the motion does not stop the program. You need to click stop if you want to halt the program, but that doesn't stop the motion. Most people just want to kill the motion. Now the other thing is the program continues to run, so if it then encounters a new command that is commanding motion while the kill all motion request flag is set, then it will halt the program. So that's why it halted. I didn't need to actually click that separately. So it's a little bit different doing the kill all motion. And then if I want to restart, I need to clear that kill, and then I can restart the program again. So that's the motion status panel in a quick synopsis. Thanks.